Okay, so we are resuming our lessons from the book, which has been a while since we were in the book. We kind of took a detour as some of those last lessons early in the unit took a route to equation solving that I did not like. So, but as we get back into this lesson, I really like this lesson as I've gone through it a couple times today with other classes. So hopefully hopefully it'll make sense, and we'll learn a few things about some proportional relationships. And this really ties back to some things nicely that I know you guys covered in Math 2. I know that because a few years ago I taught Math 2, and I remember some of these lessons that we did. So, so hopefully some of what we do, at least today, will feel familiar. We are going to compare proportional relationships. Our essential question today is our objective basically is to compare proportional relationships represented in different ways. Can anybody think of a way in which we can represent a relationship in math? It definitely involves some numbers. Variables are going to be involved for sure. An expression, you're getting there. That's really pretty close. An equation is one way. Awesome. That's a good one. You're the first class that's gotten one without a hint so far today. So an equation is one way. There's another way. Starts with T, ends with able. A table. Very good. Okay, so a table is a way to represent a relationship in math. Okay. Let's see. We have another one that would start with a G, ends with RAF.
Graph.
No, giraffe. No, graph is right. Graph. Okay. Graph. I'm glad you didn't say giraffe. A graph would be one way to represent a relationship. A chart. There are ways we can make charts that would be a little different than a table. We could do a chart. We could do a list of ordered pairs would be one way. There are other ways that we're going to get into as well. We can talk about domain and range. We can talk about mappings, and we can talk about all kinds of stuff. So there are many, many ways that we can represent things represent relationships in math. Okay, so interesting little side note here. As you go to your first slide, what is Mei Lee buying on your first on your page? Apples, and for some reason in mine, she's buying oranges. I don't know. The numbers are the same, but the picture is different, and it says oranges instead of apples. I don't know why they did that, but whatever. The numbers are the main thing that we want to talk about. So, Mei Lee is going orange or apple, whichever, picking. She is choosing between two orange orchards. The cost of a basket of oranges at each orchard is shown. And it asks, which orchard should Mei Lee choose? Now, what do we have to do to figure out why does it matter? Brady.
Because you want to know how much you're getting for the price?
Yeah, how much is this fixing to cost me? That's always what I want to know when my kids or my wife want to go somewhere. The first question I ask, how much is this going to cost me? Right? So, how do we compare these two things if we've got two different setups here?
You're going to have to combine or find like terms or something?
Okay, we're going to have to kind of put them into some like terms so that we can compare them equally. So how would we do that? Anybody got an idea?
Graph.
Put it all together.
You could divide
Divide what?
20 divided by 7.2 pounds.
Okay, close. I'm going to turn that around though. Okay,
7.25.
I'm going to set it up like this. I'm going to take this first orchard, and we'll explain it in just a minute why I'm turning that around on you. 7.25, and I'm going to set it up like this as a ratio. 7.25 over 25. And I know somebody's got a calculator nearby that you can do that math for me.
Yeah, 0.362.
Okay, now what does this number mean? Is that 0.3625 miles to the orchard? No, what does it mean?
Per apple.
Per pound.
Per pound.
What per pound?
Apple cents.
Cents per pound. It's dollars per pound. Okay, so this is $7.25 for 20 pounds. So this would be Now this is money, so
6 cents.
36 cents is what that would be. That would be 36 cents, 0.36 cents per pound. Okay, and that is, that's for the first orchard. Now, how would we find the second orchard here?
5 divided by 12.
5 divided by 12.
Are you ready? 0.41666.
Point 0.416 repeating. Okay, now it's money, so what would I do with that?
And 41 cents. You round up.
Round up, so it would be $0.42 per pound. Okay. So which orchard would she choose?
Annie.
The top one. Okay. So Annie's Orange Grove, because it's 36 cents per pound instead of Franklin's Fruit Farm because it's 42 cents per pound. You know, assuming the oranges are just as good a quality and it's not, 100 miles away from her house and all those things. But if it's just a simple choice between which one's less expensive, this one is obviously the one. Now, a minute ago, somebody suggested we put 20 divided by 7.25, and I said I was going to turn that around and I'd tell you why. Well, let me tell you why. We've got a rule. You ready for this rule? And this is not it. This is Mr. Fish's rule number 1. Okay? Rule number 1, money doesn't go on tree. Well, that's true. Except, she's selling oranges, and that's kind of like throwing money. Money goes on top. When we set up our ratios, we want money to go on top. Now, this is one of those rules that every now and then we'll find an exception to, and I'll help you with those, and I'll point them out when we see them. But it's almost always that money is going to go on top of our ratios. And we'll talk more about why those rules are as we get deeper into these lessons and we kind of see how these ratios work. We'll talk about why that is, but for now, that's the rule. Money goes on top. Okay. So where does money go?
On top.
Thank you. All right, it goes on top. All right, so let's move into the next section. I'm actually going to have to switch screens here, which I hope works with the recording. It may actually I may have to finagle some things here. I'm going to have to move my screen around a little bit. Okay, so in your curriculum, there's this video that that goes with the next section, and I want us to do this video or watch this. So let me find my. There we go. All right, you ready? Well, I assume you are. There we go.
How can you compare proportional relationships?
Sorry about that.
In different ways? Think about this question during the lesson. Mira is researching cruising speeds of different planes. She has a table of data on the Cessna 310, time in minutes, and distance in kilometers. Mira also has a graph for the Boeing 747. The point 1, R, represents the unit rate. Which airplane has a greater cruising speed? Let's find the two speeds. First, we should find the cruising speed of the Cessna. How do you find a cruising speed?
So I think you can already see some slides in your book, right, where it kind of advances through to the next step. And what are they going to do with this table on the next screen?
They're going to put the distance on top.
Yeah, the distance is going to go on top and the time is going to go on the bottom. We'll talk more about that in just a minute, but because that's going to follow one of the rules we want to learn. So we and they're going to find a unit rate, and that's I kind of failed to mention in the last slide. If we went back to that one real quick, when we found that dollars per pound, that was a unit rate. We were finding how much 1 unit of oranges cost if we talk about the pounds of oranges being 1 unit. So unit rates are kind of a big deal in this chapter. So they're going to find that unit rate. Let's see how they do that. She's going to show us.
The cruising speed is the same as the unit rate. Mira can table to find the constant of proportionality.
Pause right there. Have you ever heard that phrase before? Constant of proportionality. Everybody should be nodding your head or saying yes, because I know you've heard that phrase before, because I've taught math too before. So that's a big deal here in this section, constant of proportionality. So if you're forgetting that, or you don't remember that from last year, kind of search your memory banks a little bit and see if you can come up with some things about constant of proportionality. We'll talk more about that in a minute.
Distance over time.
Okay, so in this part, we know how to do this, right? We would do 40 divided by 5 is 8, and 120 divided by 15 is 8, and 240 divided by 30 is? Okay, are we surprised that it's the same unit rate all the way across? We shouldn't be surprised that it's the same unit rate, because it's the plane's traveling the same speed all along, right? This plane's speed does not change. And so the comparison of time to distance never changes. That unit rate will stay the same. All right?
In each column, the constant of proportionality is 8. So the Cessna's cruising speed is 8 kilometers per minute. Now, we need the cruising speed of the Boeing 747. To determine the constant of proportionality, Mira can find the difference between any two pairs of coordinates. There are many points on the line, but not all of them have coordinates that are easy to read from the graph. Mira could choose these 2 points, for example. The graph has a run of 2 and a rise of 30. The ratio of rise to run is 30 to 2, or 15. So, the Boeing has a cruising speed of 15 kilometers per minute.
I'm going to save this slide real quick, because I want to talk about it more in a minute when I can write on it. So I'm going to put it over here. There we go. Whoops. Now we can go back to the video.
The Boeing 747 has a greater cruising speed than the Cessna 310.
Okay, so that ends the video. If we go back to this slide here, there's a couple of things that she talks about right here that are really important for things that we have coming up in the next couple lessons. Do you remember what she called, I gotta get my pen, can't see it, there it is, which is right there. Do you remember what she called this right here when she,
Isn't it like out or grow?
you're on the right track. She called it the run. Okay, that's what you were thinking. You should have said it, because you look like a genius. Okay, well, yeah, but you would have been right, and that would have been awesome. Okay, now, do you remember what she called this?
Sprout.
The sprout.
Up there.
It also starts with R.
The route.
Round.
The road. Right.
Right.
The riz.
Right.
Nice try. All right. So the rise and the run, and she went through this, and it's really interesting how this works. It's kind of a cool deal. The run is 2 and the rise is 30, because we always count by the way the graph is numbered, right? From 20, and this is goes up 15, that'd be 75, 80, and then it goes up by 1s in the x direction. So that the run of 2 and the rise of 30. Okay, but look what's cool about this also, though. What if I had just taken the ordered pair 40, or 4, comma 60, and what if I just put the y value over the x value? Whoops. The y value over the x value is 4. What is 60 over 4? 15. And what is, if I just take this ordered pair, 690, and I just put the x value or the y value over the x value. What is 90 divided by 6?
15.
It's 15. Okay? And so with a proportional relationship, there are so many ways that we can see that constant of proportionality, that unit rate, right? Constant of proportionality shows up over and over and over again. It shows up with the rise and the run of the graph. It shows up with the ordered pairs. It shows up here in a minute. We're going to see it in an equation. It just shows up over and over and over again. Okay, so that is a really important number for us as we work on proportional relationships. All right. Is this the next one for you?
Yep.
Okay, I left one of them out that there's one problem in here I didn't care for, so I left it out of your notes, but we'll skip that when we get to it. The graph represents the rate at which Daniel earns points in his video game. The rate Brianna earns points in her video game is represented by the equation y equals 2x, where y is the number of points and x is the number in minutes. Okay, let's pause right there for a second. So Daniel's is represented on the graph, right? Yes?
Yes.
Okay, it says right there at the top, graph is Daniel's information, and the equation is Brianna's information. So when you see this, y is the number of points. Is there anything on Daniel's graph that shows you that these are related? Like we're judging the same things for each person?
Well, the Y arrows, like the points.
Yeah, the y-axis, that's what we call this line here. The y-axis is the number of points. Well, look at that. In her equation, the y stands for the number of points. That's what exactly the same thing for Daniel. What about for her? It says in her equation, x is the time in minutes. Does that relate to Daniel's graph?
Yes.
Yeah, the x-axis is the time in minutes. Okay? And so we've got it going on here. The equation and the graph represent the same data. That's good to know. That means we can compare those two things. So, to find Daniel's constant of proportionality, what do we need to do?
Daniel, you put the y over the x.
Put the y over the x. That's exactly right. And so what do I need to put a y over an x? I need an ordered pair. So what ordered pair can you read on that graph?
6 and 2.
6 and 2. Okay, but say it in the right order, because how do we write?
2 and 6.
There you go. We write ordered pairs x first. So 2, 6. And then if I'm going to find the constant of proportionality, I've got another rule. I haven't told you rule number 2 yet. You ready for rule number 2?
I am ready.
Rule number 2. Time goes, where do you think?
Bottom.
On bottom. Time goes on bottom. Okay? When I'm setting up a ratio, I want to put the time on the bottom. Again, every now and then we're going to see an exception to that, and those are rare, but they're usually kind of obvious when it happens. It's going to be something, kind of a weird scenario. So, but we can just get in the habit of always putting time on the bottom of our ratios, and that's going to help us. Because almost always we're going to want time on the x-axis. We're almost always going to want money on the y-axis. That's why those rules are there. Okay? So Daniel's constant of proportionality is y over x, which is
3.
3 divided. Yeah. So, by the way, going back to math 2, do you remember what letter we use for constant of proportionality?
C.
It's not C, and it's really weird that it's not C, but it's not. If the word constant didn't start with a C, what would it start with? It would start with a K. And that's what do you remember that? Why? Do you remember an equation in math 2?
It was like
Y equals KX. Very good, Kevin. K for Kevin. Good job. All right. Y equals KX is our constant, is our proportional relationship equation, and K is our constant of proportionality. So Daniel's K value is, for Daniel, K equals 3. And so we would say his equation is Y equals 3X. That's Daniel. Now, what is Brianna's K value?
K equals 3. No.
What is Brianna's K value?
3x. Oh.
3 or 1. 2x.
Not 2x.
YX. It's y equals 2x.
That's her equation, y equals 2x. Which one of those? There's three things there. There's a y, a 2, and an x. Which one is the k?
The
X.
x.
The y. The 2. K is the
Y is the y. K, x is the x. Which one is the k? It's the 2. K is 2. All right. So for Brianna, that was fun. Thanks. Daniel, this is all Daniel right here. His K value is 3. Brianna, her K value is 2. So y equals 2x. So which one of them is going to get to 100 points faster?
Yeah.
Daniel. Why Daniel?
Because he has 3
What does that mean? 3 what?
minutes a minute, or 3 points.
3 points per minute. So if he's getting more points every minute, he's going to get to 100 points faster. Okay. All right. So we learned a lot there on that slide, or remembered a lot from math 2 at least. The K value is going to be very important for what we're doing the next couple of lessons. Rule number 2, time goes where?
or I'm on bottom.
What's rule number 1?
Money goes on.
Money goes on top. All right, there we go. Okay. So let's look at another example. The graph represents the cost per ounce of a granola cereal. Yum. All right. So the graph is the granola cereal. A 15-ounce box of raisin cereal costs $3.90. Which cereal costs more per ounce? So we're looking for the one that's most expensive. All right. So how would we find the cost per ounce of our granola cereal here?
You do 3.9 divided by 15.
That's nope. I said granola.
Oh,
Granola cereal is this one.
Oh,
you would do
look at y.
yeah.
Which would be 5.
Which x and y value can I see clearly on this graph?
20 and 5.
20 and 5. So if I take 20 and 5 and I set them up as a proportion, a ratio, what number needs to go on top?
Top 3.90.
The money goes on top, right?
So it'd be 1. It would be 1 over 4
Well,
or 5.
K equals 5 over 20, and just divide it.
It'd be 1 over 4.
5 divided by 20, not 20 divided by 5. 5 divided by 20.
Oh, it'd be 4. 0.25.
0. Yeah.
Huh?
0.25.
0.25. What? 0.5.
0.25 because 5 divided by 20.
Yeah. Because 5 divided by 10 is 5. Oh, 0.05. It's 0.5. 0.25.
0.25, really? Okay, they lied to me last hour. All right, 0.25. All right,
What did they say?
don't worry about it. All right. 0.25. So that's my K value. All right. Now, I want to find my K value for a 15-ounce box of raisin cereal.
It's 3.9 divided by 15.
3.9. Oops, I don't know why I wrote 3.5. 3.9
It's
divided by 15.
0.26.
So K equals 0.26. Okay? So which one is more expensive? The raisin cereal is more expensive than the granola cereal. Okay. And so that is, I mean, that one's pretty straightforward. All right. the next page that you have there on your in your books is like the review page. So
I think we're good.
think we're good.
I don't think we.
So your assignment is on page 125
Yeah.
and 126. All right.
Assuming if you're not done.
Yes, it is an assignment. All right.